Hello, I am Matai from the RoboRoos East FLL team. Today we'll be continuing on with our XY coordinate system. We already know how far we need to go to get to the wanted position. We know where we are at the moment. Now all we have to do is find the direction to the wanted position to put together a working movement. But before we get started on that, we need to make an adjustment to the tracker. So you have to go back into it, and you have to add a maths block after the gyro read and set it to multiply by -1, and then select the gyro read in that maths block and go to tools, my block builder, and call this block corrected gyro. And all I have to do is give it an output, but it should automatically set that if you've got the latest version. And you can give it whatever icon. I'll just give it a gyro. And the piston should just be angle. And so then just click finish and just readjust all of the different blocks to how you want it to be. And then inside of this, you have to make sure to go back to corrected gyro 2 and move this output into the maths block, and then move the output from the maths block here. And now that should all be fixed. And the reason we need to do this is because it fixes the gyro, as the gyro measures degrees in a clockwise direction, but the values used in sine and cosine are assumed to be counterclockwise, so we just have to invert it. So last time we covered the trigonometric ratios sine, cosine, and tangent. But today we'll focus on tangent, which was opposite over hypotenuse. The only difference is, this time we know the length of the two sides, which is the length of the x and the length of y, and we want to find the size of the angle. So what we do is that we have to use something called tan, or inverse tangent. So you can essentially use tan of, in this case it'll be y over x, to find what the angle is. The only problem with this is it all breaks down if x equals 0, so we do have to add something in it to make sure that doesn't happen, and we also have to work with negative numbers for x. So now we can actually start creating the block. The first step is finding the length of each side, and to do this we have to create the last x variable from last time, and the same goes for last y, which is here, and then add a maths and another one of each for both of them. And for these we're going to create new ones. You have to create one called delta x, and then you just have to do the same for delta y. Then just set these two to read and set the maths blocks to subtract, and plug the x last into port A and plug this into delta x, and do the same for y. And so what this is going to do is we're going to put our wanted x and y positions into the B ports, and so this will just find the length of the x side and length of the y side, which is the two sides we need to find out the angle. Okay, so now we can get into the actual logic behind it. So first you want to create a delta x variable, and it's just making a new line, but you don't have to. Then set it to read numeric, and add in a compare block, and set that compare block to equal 0, and plug in the delta x variable. Okay, so next you have to create an if statement and set it to logic, put it into tabbed view, and plug that in. So in the true state, we want to check if delta y, so just get a read variable, delta y, then add in another compare, and set this to test for a value greater than 0. And then you have to make another switch inside So yeah, just set the switch to logic and plug in the compare. Okay, so now in the true state of this, you're going to want to create a new variable called heading, and then set that to 90, and then just copy this over and make heading negative 90. So essentially what this means is if there's no change on the x, then if the change on the y is positive, set it to 90, and if the change on the y is negative, just make it set the angle to negative 90, because those are the only two possible values. So now in the false tab, which if you remember will trigger if delta x is not equal to 0, you can create two variables. You need to create a test for if delta y is equal to or greater than or equal to 0. So that's just this one right here. And you have to make sure to use greater than or equal to, or you will have some problems. Then you have to put in a switch, another switch, yet again, and plug in the output. And so now, in the true state, what you're going to want to do is you're going to want to make two variables. And just like that. And you should set the first one to be delta x and the second one to be delta y. And then you need to put in a maths block and set it to advanced. And what we're going to have to type in here is a10 of b over a, and make sure it's b over a, and then plug delta x here and delta y here. And this is one of the reasons we had to modify the tracker, as otherwise we would have a problem with the arranging of x and y, and it would just be very difficult to solve without it. And then you can just make the heading right here and plug in the results from the A10. So now what you're going to do is you're going to take this and copy it over to the false state, but with this one in the false state you want to go into the maths tab and go plus 180. And so what this means is that if the vertical change is negative, then we're going to make it inverted angle. So instead of like 45, and it will give you 225, and that's just because there's technically two values that A10 can give you, so you have to be sure to specify whether it's negative or not. So now outside of the main switch, you can just create a heading read variable. Okay, and now what you can do is you can take everything you've done and turn it into a my block called wanted direction. And add two inputs and one output. And the first input should be called wanted x. Second input should be called wanted y. And the third input should be called wanted direction. And then you can give them appropriate icons. For wanted direction, I'll use this. And there's very handy x and y things here that we will use. And we'll just keep this logic symbol for now. Then click finish. And then just take a bit. And so what you can do here is you just plug in the x here, the y into here, and then right at the very end, you can take this output, and bring it down here, and plug the heading variable into that. And so now you've got all the components necessary to build the movement, but we'll be going through that as well as a few necessary initialization things in the next episode. And so thank you for watching, and see you in the next episode.